All right, this is the review for Unit 3, so I'm going to work it out here. So pause, rewind if you need to see something again. I'm going to run through this review with you. Okay, so number one here, we are just simplifying. We're going to run through pretty much the exponent properties here in number 1, A, B, and C. So the first thing I usually do is if there's not a parentheses, like there is in B, there is not in A, the next thing I look at is negative exponents. Now, you can approach this two ways. You can just subtract the exponents as we are in division here, but I'm going to just kind of circle, remember the bad bases, so any of them with a negative exponent. So those three need to move. So if I rewrite this, the y5 is fine on the bottom, like that. So it's going to stay there just because it's positive. One of the mistakes I see is kids wanting to move it to the top because it's positive. Remember, we only move the ones with negative exponents. So that x to the negative 3 is going to actually go to the top, and it becomes positive. The x to the negative 9 is going to go to the bottom and become positive. And then that y to the negative 2 is going to also move to the bottom and become positive. So I've taken care of all those negative exponents. So those two move to the bottom. That one moved to the top. And that one stays put because it did not need changing. Now you can apply some of the easier properties of exponents. These two are being multiplied. So we would add exponents. So we'd have a y7 on the bottom. And now we have a subtraction with the x's. You could say 3 minus 9, that's a negative 6, and we'd end up having to move it to the bottom. Or you can just subtract from the bigger number. So 9 minus 3 is 6. And where are those extra x's? They are on the bottom. Remember, if there were 9 x's on the bottom and 3 on the top, you would cancel out that and you'd have 6 x's on the bottom. So something has to be up top. It's not a 0. It is a 1. So there is the simplified answer to letter A. All right, B. We do have a power here raised to other powers. So we are going to take care of that parentheses first. Make sure each base has an exponent. I'm going to put that invisible 1 on my negative 2. So now distribute that 3 into each exponent. And the mistake we'll see on the test is kids will take that negative 2 and multiply times 3. That is not what we're doing here. 3 times 1. So we get this. 3 times 1 is 3. We're going to raise negative 2 to the third power, not multiply. Then the x. 3 times 5, 15. 3 times 3 for the y is 9. And then if you have a number raised to an exponent, go ahead and calculate that on your calculator or Desmos to simplify fully. Now, when it's negative, make sure you're using parentheses or you will get a possible wrong answer. So I'm raising that to the third power, and I get negative 8. Negative 8, x15, y9. There is the simplified answer. Okay, letter C. We have a whole bunch of multiplication. We do have parentheses, but no exponents on the outside. So this is all just straight multiplication. So look at your big numbers first. We multiply those. We don't add them, subtract them. 5 times negative 3, negative 15. And since we're just multiplying everything here, those parentheses kind of throw us off. We're just going to add exponents, remember. So 2 plus negative 4 on the x is negative 2. So that will have to be moved at some point. Now the y, we have -1 plus 2, which is +1. All right, so that is bad. Remember, we're going to have to move that. Circle that one. Remember, any number can be written on top of 1. And I'm going to move that down to the bottom to make it positive. So the -15 stays. We don't move that because it's a negative number. Only negative exponents. So -15 and the y, you can put a 1 there. You don't have to. They stay up top. But that guy has to go down, and it becomes positive. And then that is the final answer for C. Okay, moving on to 3.2, which is where we rewrote rational to radical and radical to rational. So in this first three, we're going to rewrite into rational exponents. So we're given the radical, and we're going to change it to exponent form. So you start with your base. That's a 6, and you raise it to whatever that exponent is. Remember, it's an invisible 1 over the index. So it's 6 to the 1/4. It says then simplify if possible. So I'm going to just double check if that can be. I know it can't, but we will check here. So that is a decimal. We cannot do anything with that. That is the final answer. Okay, letter B. Here's my base, 2. And then raise it to the 2 over 6. Like that. So we're going to simplify that exponent to 1 over 3. 2 to the 1/3. So that's all we're doing on these, changing from radical to rational exponent. There's the questions on the test are in the same format, I believe. You're going to have a couple like this, and when we get down to number 3, we'll talk about that more. All right, so each base will get that exponent and that index. Remember, the invisible index on a normal square root is a 2. If there is not a number out there, it is a 2. That's 64. Give it an exponent. So we start with the 64, raise it to the 1 over 2. Remember, a square root is to the 1/2 power. Move on to your next base of x to the 7 over 2. Move on to your next base of y to the 10 over 2. And then just simplify anything you can. So 64 to the 1/2, let's look at that in a calculator. So the square root of 64, hopefully you know that is 8. But we will take a look. 64 to the 1/2 is 8. So we get 8. 7 over 2 cannot be simplified. And then 10 over 2 can be simplified to 5. 10 divided by 2 is 5. So there is the answer to that one in rational exponent form, radical form. Rational exponent, radical. Okay, so with number 3, like I've prefaced before, we're going to take exponent properties to simplify these. Then down here, we're going to switch to radical form. So the test looks just like this, where you're given some of these, and these are usually widely missed every year, just remembering our exponent properties, then being able to switch to radical form. So you do it the same as we did up here with these guys, just now we have fractional exponents, rational. So exponent to exponent, you multiply. That is just x to the 3/4. So you would multiply 1/4 times 3 on your Desmos or your calculator. 1/4 times 3. And there it is, 3/4. So x to the 3/4. And that's it. It just says simplify. We'll take care of radical form down here. Okay, that is done. All right, these are in parentheses, but that just means they're being multiplied. There's no outer exponent, so we're just multiplying these two bases, and when we multiply like bases, we add the exponent, just like we did up here. We multiplied these two, so we added the 5 and 2 and got 7. So we're going to add 1/5 plus 7/5. And if you're good at fractions, that is actually 8/5. But I will show you. 1/5 plus 7/5. And I know that's a little blurry or hard to read there, but there it is, 8/5 or 8/5. No need to simplify that farther. We don't want to mix numbers. So that is it for that one. So these are pretty quick little problems here. Okay, a two-parter. We have, this is basically what we did here, and then we'll get an answer, and we'll then have to do what we did there. So first things first, x to the 2 times 1/3. If I put that in the calculator, it's 2/3. Then I'm doing this one. And I'm going to put a multiplication dot there because that's all it means when they're next to each other. 3 times 2/3. 3 times 2 is 6/3. And that could simplify down to 2, but it's going to help me out right now. So we're multiplying just as we did here. So we added. So 2/3 plus 6/3 is 8/3. You just, when the common denominator, you just add the numerators. But again, plug it in a Desmos or a calculator if you're not good with fractions. Okay, so those three are done. And now the simple process, we're going backwards from what we did up here. We went from radical to rational. Now we're going from rational, write your answers from number 3, all these guys, in radical form. So I know I have a radical. I'm going to take my base of x, and now you just have to do the opposite you did up here. Our denominator, remember, is the number out left, left bottom, top right. So the bottom 4, well, helps if you can see it, the 4 is going on the left, and the 3 will go to the right as the power, or the exponent. And that's it for that one. B, again, give your radical. The base is an x. And the denominator goes to the left. The top number is your power, or exponent. So again, those are pretty quick if you can remember the order. And the last one, again, you need a radical. Our base is x. Bottom left, top right. Okay, so that's it on the radical to rational and rational to radical. All right, that's the front page. Okay, then we're down to the solving. So those last two sections, 3.3 and 3.4. You're undoing the equation, so don't try to do anything other than that. It was like the last two questions on the last test. We want to solve for x, so undo, unwrap everything around the x. We can't add 3 yet. It's in parentheses. We have to get rid of that 5. So you could multiply to the 1/5 power, or we could just take the 5th root of this side, and whatever you do on the left, you need to do on the right. That cancels out that power of 5, leaving us with an x minus 3. Remember, the index matters here. Odd index, 1 answer. So we're just not going to have that plus minus. I'm going to see if that is a perfect 5th root. We have the 5th root of 64, and it is a decimal. So make sure you're not just writing that decimal out. We're going to have to factor tree this. And 64 is 8 and 8. Remember, an 8 is made up of 3 2s. And we're looking for a group of 5. There we go. So we have a 2 come out. Don't forget the little 5. And what's left? That singular 2 right here. So that goes on the inside. So if you happen to get these two mixed up, it won't matter because you'd have had a 2 out front and a 2 inside anyway. Last step, add 3. This is a good one here. So our answer is not 5 to the 5th root of 2. Remember, these are separate. They're not like terms. We can't combine them. So we have a positive 3, and then you add the 2 5th root of 2. Okay, so there's your answer right there. So that's what it means by exact form, is having the radical in your answer and not the decimal. You'd think it'd be the other way around, but decimals you have to round, therefore it's never exact. All right, letter B. First one is getting rid of the 7. 2x to the 4th equals 162. And this is a good one here because I know kids are going to go right to getting rid of the 4. Got to get rid of that 2 first. You got to unwrap it. Get rid of the 2. X to the 4th equals 81. And to get rid of the 4, 4th root both sides. Now we have an even index. 2 answers. So that cancels. You have plus or minus, and then we'll see if there's a 4th root of 81. All right, and there is a 4th root of 81. It is 3, so a perfect 3. So we get plus or minus 3 with nothing else to do there. All right, then we move on to our last section, 3.4, that had the exponents as fractions. So we still want to get rid of that negative 2 first. X to the 3/4 equals 8. All right, and this is the fun one. I don't know why, but I like this. To get rid of that 3/4 power, we raise it to the 4/3. 8 to the 4/3. Remember, whatever you do on the left, you have to do on the right. Look at your denominator. If it is even, we would have 2 answers, but the denominator that we applied is odd, so we just have 1 answer here. So I'm going to cancel that out, and we get, let's see what that is, 8 to the 4/3. 4 divided by 3. I think this is going to be a good number. It is 16. And just that one answer, 16. All right. One more of these. We're getting rid of the 3 first. Anything outside the parentheses. X plus 2 to the 2/3 equals 4. All right, we're not subtracting 2. We are down to the exponent because of the parentheses. So raise it to the opposite, or reciprocal, rather. 3 over 2. 3 over 2. Even index. 2 answers. Even denominator means it's an even index. So it cancels out. X plus 2 and 4 to the 3 over 2 is 8. However, we have 2 answers, so it's plus or minus 8. And these are the fun ones. Subtract 2. X equals positive 8 and negative 8 minus 2. Remember, it's not plus or minus 10. 8 minus 2 is 6. Or I'm sorry, plus or minus 6. We get 6. And then negative 8 minus 2, that's where that negative 10 comes in. So 2 separate looking answers. All right, and the last one is just a word problem. So it's talking about antelope bone size, length versus diameter. But basically, they give you an equation right here. And then they're going to probably tell us we need to know either the L or the D. So L is probably talking about the length. D is talking about diameter. If the length is 20 millimeters, so I'm plugging 20 in for L, I'm going to now solve for D. So your first step, would be to add 8. $28 equals 24.1. D to the 2/3. Okay, so we got rid of that -8 on the end. And now here's where I see kids kind of run off the rails. That's like 2x to the whatever. So we got to get rid of that number. We need to divide by 24.1 on both sides. And it's okay to get a decimal when we're dealing with word problems here. So 28 divided by 24.1 is 1.16. I'm going to round it, 1.16. All right, now we just have to get rid of that 2/3. So we will raise it to the reciprocal, 3 over 2, 3 over 2. And we're going to get another decimal here, but that's okay. So the D is the diameter, 1.16, raise it to the 3. And we'll get 2 answers. We'll get plus or minus, but again, you can't have negative diameter. That doesn't make sense when you're dealing with area, volume, length, width, height, that kind of thing. So we get 1.25 if we round it, plus or minus, but again, you can't have negative diameter. So 1.25 is our D, and it said the diameter is in millimeters, so 1.25 millimeters is the diameter of that bone. So that is the review for Unit 3. So if you still need assistance with some Unit 3 material, I have the quizzes going over several of these sections, so attempt those.